Welcome to the MSAG Online UK CAT course. In this video we will show you how to perform speed, distance and time calculations. Questions involving speed are relatively common in the UK CAT quantitative reasoning subtest. You will likely get one set of 3 or 4 questions on this topic. Getting those questions right could make all the difference in terms of your scoring, so we're going to spend some time specifically on these types of questions during this video. Our objectives over the next 5 minutes or so are to teach you the speed, distance, time triangle that will eliminate any confusion as to whether to divide or multiply, and show you some of the different ways you can be asked to perform speed, distance, time calculations. I guess that time is of the essence, so let's begin. First of all, what is this triangle that we mentioned? Take a look at the diagram on screen now. So, how do we use this triangle? Really simply, you cover up the value that you're trying to find. If we're looking for the speed, cover that up with your finger, and what do you see? Distance divided by time. Looking for the distance, cover it up. You can now see that you should multiply time by speed. The box on the right shows the different results from using this triangle, but all you really need to remember is the triangle itself and how to use it. In the exam, you can abbreviate this triangle to d over s multiplied by t. Let's practice this truly magical triangle with some examples. Question 1. Train A travels at a constant speed of 120 km per hour. If the train starts at station X and travels to station Y, which is 35 miles away, how many minutes will this take? Will it be A, 17.5 minutes, B, 20 minutes, C, 23.5 minutes, D, 28 minutes, or E, 31.5 minutes? Pause the video and have a go at this question yourself. Aim to take under 30 seconds. First, let's deal with the pesky conversion. We can't have one value in miles and the other value in kilometres per hour. We are given the conversion that 1 mile is equal to 1.6 kilometres. So let's multiply 35 miles by 1.6 to convert it into kilometres. 35 multiplied by 1.6 equals 56. The distance the train will travel is 56 kilometres. This video is not focused on conversions, but I've picked this sort of example to demonstrate the complications that can be thrown into some of the speed, distance, time calculations. Now it's time to use the triangle. The question is asking for the time the train will take. So we cover up time on our triangle. You should see that this means to find time, we must divide distance by speed. Some students will be tempted to do 120 divided by 56 because they're used to putting the bigger number on top, but I'm hoping that you won't, because you'll remember to use the triangle. Distance divided by speed means 56 kilometres divided by 120 kilometres per hour, which equals 0.4666 recurring. Remember, this time is in hours. We must multiply our answer by 60 to convert to minutes. 0.466 recurring multiplied by 60 gives us 28 minutes. Therefore, option D is the correct answer to this question. One more example should solidify this method for you. Take a look at the table on the screen. It gives information about the average walking, jogging, running and cycling speeds of Sarah and Chen. The units are meters per second. Now, question 2. After school, Sarah and Chen decide to get in some exercise along the straight path to the library. If Sarah decides to jog and Chen decides to run, how much farther ahead is Chen after 3 minutes if they are both moving at their respective average speeds? Is it A, 7 meters, B, 8 meters, C, 468 meters, D, 469 meters, or E, 508 meters? Pause the video and try this question using the method we have learnt earlier. How did you do? Start by pinpointing what question it's asking for. In this case, we need to find the distance the 2 individuals have travelled. Then, use the triangle to see which calculation we must perform. Covering up distance, as this is what we are looking for, gives us time multiplied by speed on the triangle. Be careful though, the time is given as 3 minutes, but the speeds are given in meters per second. Multiply the 3 by 60 to convert minutes into seconds. 3 multiplied by 60 equals 180, so they both have 180 seconds to either jog or run. We know that Sarah is jogging at 2.9 meters per second and that Chen is running at 5.5 meters per second. We could work out their distances by using the triangle for each of these values, but there is a shortcut you can use to get to this answer a bit more quickly. The question is asking us for the difference between the 2 distances travelled. and there are no marks for knowing how far each of the students travelled individually. Since we know that they are both travelling for the same amount of time, we can do just one speed distance time calculation using the difference between the two speeds. 5.5 meters per second minus 2.9 meters per second is a difference of 2.6 meters per second. Use this relative speed to calculate the difference in distances travelled. We know the time, 180 seconds, and the relative speed, 2.6 meters per second, and our triangle tells us to multiply time and speed. 2.6 meters per second multiplied by 180 seconds equals 468 meters. Chen is 468 meters farther ahead. The answer is therefore C. We hope that you now feel much more confident in performing speed distance time calculations. The triangle is a really useful tool for taking out the confusion in such situations. I challenge you to memorise that triangle so that you won't forget it in a week, in a month, or even the next year.